So does that kind of clear things up for that first question, guys? Because I know that first question is a little tricky.
Yes, it does. Thank you.
Of course. Any other questions from last week's homework you guys want to discuss before we move on? Christina, I noticed you came off mute. Do you have something?
No, I was just going to make, I don't want to, yeah, I think you explained it well. I think with that question, where I struggled is I did health economic outcomes research in pharmaceuticals for a long time.
Yeah.
And so in the real world, you would always have a screening procedure before you gave a medication, even if it's brand new. And so that's why that tripped me up, to be honest with you. But then when I read it a couple of times, it kept saying new medication, new medication. And then I went down the rabbit hole of like, could you ethically do this and like select a piece of population that you wouldn't treat with a medication if they had a stroke and you couldn't, right? So like I was going down that real world rabbit hole. So I just think it's the way it's worded, but
No, Christina, I'm so glad you mentioned that because, and darn it, I apologize. One of these days I'm going to have to remember to mention this, but every single time I teach this class, this same question of ethics comes up. And what I forget to mention to the students is that when we're talking about all of these questions, you have to think about them in a vacuum. Don't apply real world logic to them, as far as you can't think of these things happening in the real world. So for instance, when it asks you to then think of how you could eliminate those confounding variables, you're absolutely correct. There is zero way that you could ethically eliminate those variables, because really the only way to test whether or not the new blood clot medication works would be to randomly let some patients have it and then randomly not let other patients have it. Well, that's completely unethical and probably illegal, and would absolutely, if at a minimum, open you up to a whole boatload of litigation. So it would never happen. That's why they have clinical trials, because in clinical trials, the people in the trials know that there's a chance that they're getting the new medication, but there's also a chance they're getting a placebo. So, they're legally and ethically allowed to do those kinds of things. We couldn't do that in the situation described in question 2.2. And unfortunately, Christina, you're not the first student to have that same go down the rabbit hole quandary of like, oh, well, this can't be right because this would be unethical and da, 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 da. Anytime a student has any kind of medical training in this class, these questions always trip them up because they're thinking about it, as someone who's been in the medical field going, well, you can't do this. Well, I know I can't. This is a thought experiment. We're supposed to be thinking about this outside of reality. And so that's where it gets tricky. And I don't think there's anything else in this course, but if there is, always remember that every homework question, every piece of the mini project, every piece of the final project is all supposed to be looked at through the lens of a theoretical scientist. Sure, the questions are given to you with a real world context, but that's only so you can see the real world context of it. Do not evaluate it with that lens. You always want to evaluate it in the pure vacuum of a theoretical scientist perspective, where you can play God and you can screw with things and you can do completely unethical things because we're just thinking about how the numbers work and how the stats work. And we're not worried about the horrible things it would do to the humans that are involved in these theoretical scenarios. Does that make sense?
100%.
Awesome.
Thank you.
No, thank you. I like I said, I should have brought that up earlier, but yeah, that is a completely valid question. Okay, anything else? All right, then let's run through this week's material. Grading status of week 1. Well, as I said at the beginning, I unfortunately completely forgot. I graded everything that was turned in early over the weekend and then woke up this morning going, yay, grading's done. And then was like, oh no, dummy. There's all the people who turned the stuff in on Sunday. So I haven't graded stuff. I'll get to it later today. Okay. This week.
Dr. McBride?
Yeah,
Yeah, I have one question on you just because you had it on there about the data sets that are coming from the textbook, and I know they're in the Google folder, the Google Shared Drive.
yeah.
But before the end of class, can you just, I know there's 2 data sets related to the mini project, and I just want to make sure I understand what it looks like there's 2.
Yes,
And I want
there
to make
is.
sure. Okay.
And I'm
I want to
glad
make
you
sure.
asked that. Yep.
Okay.
So the 2 different ones. So the mini project, there's mini project new drug data. That is the standard data set for the entire mini project. So if I open it, you'll see that this will have all the variables. So this is all the data that you would need to run basically all the questions. However, there's one part of the mini project where they ask you to create a side-by-side box plot. The only way to get SAS to produce a side-by-side box plot is to have all of your data under one variable. So in this case, they want you to do a side-by-side box plot comparing the BP before to the BP after. You can't do it like this because they're housed under 2 variables. And when you go in to do a side-by-side box plot, you tell it, okay, I want to do BP before and I want to do BP after. And all it's going to do is going to spit out 2 separate box plots. They're not going to be side-by-side on the same axis. In order to get a side-by-side box plot on the same axis, you have to use this set of data, where what I did is I took all of the BP data and I put it under one variable called BP. And then I gave it a category variable, BP cat for BP category. And you can see that all of this data is the BP before, right? Because it says before. And then as you scroll down, you see here's all the BP after. So by putting it under one variable, you can now go into SAS and say, create a box plot, and then use this categorizing variable to break the data up and show me the 2 box plots in one graph. And that's how you get a side-by-side box plot. So that's why there's 2 sets of data there. I basically just did the combination for you rather than telling everybody, hey, the only way to get this to work, you got to put all your data under one variable and then have a category variable. And then everybody's like, what the hell do you mean? How do I do that? I'm like, I don't want to waste time with that because that's not important for you guys to learn how to, do this. This is just data manipulation.
Much appreciated. Thank you.
Yeah.
Thank you.
Of course. Great question. I'm glad you brought that up. Okay. So this week, it's all about measures of center, measures of variance, measures of relative standing. Measures of center are the ones that you're probably most familiar with. I think we all know what the mean is, right? The mean is just simply the average. I think most of you have probably heard the word median. If anything, you've heard it referred to the big cement barrier that goes down the middle of the highway that you slam into at 2 o'clock in the morning because you're texting or you fall asleep. But that will remind you, because it goes down the middle of the highway, the median is the middle of your data, i.e. you have to sort your data from smallest to biggest, and the median is literally halfway, right in the half point. And then, of course, the mode is the most common or the most frequently occurring data value or values. You can have multiple modes in your data set. So here's some simple examples, right? If we wanted to find the middle, the median of this data set A, we can see that data set A has 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data. So the middle of our data is right here with number 5, the 5th data, right? So 1, 2, 3, 4, 5, it's the second 7. So the median would be 7. Now down here, we have 8 pieces of data. So the median lands right in between the 4th and 5th. So it lands right in between 7 and 8. And we would take the average, and the median of this set of data would be 7.5. And we can do this all day long, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So with 9, again, we got to go 1, 2, 3, 4, 5, right? So it doesn't matter what's going on. The middle is always the middle, whether it's even or odd. If it's even, it falls in between 2. If it's odd, it lands on something. They talk about finding modes as, counting frequencies. So if this was our set of data up here, we'd say, okay, the data value 1 showed up twice. There were 1, 2, 3, 4, 5 of the 2s, right? 1, 2, 3, 4 of the 3s, 2 4s and 1 5. So obviously 2 is the mode. But if I went up here and I added another 3 so that there were 5 2s and 5 3s, we would have 2 modes. And it would be 2 and 3. You wouldn't say 2.5. You wouldn't average or anything. You would just list them both. Say there's 2 modes, 2 and 3. Okay. If all of your data values showed up 5 times, I had 5 1s, 5 2s, 5 3s, 5 4s, and 5 5s, what would the mode or modes be at that point?
No
The
more.
twos.
So good. Thank you for playing. Yes. So good guesses. I think somebody said all and somebody said none. I'm not sure, but those are the 2 obvious answers. It's none. So a lot of times students think that if everything shows up more than once, then they're all the mode. But remember, the mode has to be the most frequent. So if everything showed up 5 times, there would be no mode because they all have equal frequency. Just like if everything showed up once, there'd be no mode. You can also have modes when you have class data, right? Data that's put in classes. These are sometimes called bins, where you've got, okay, so there were 5 numbers that were between 20 and 30. And then you had 8 of them that were between 30 and 40, and so on and so forth. So you can see here, this class has the highest frequency of 10. So you wouldn't say that the mode was 50 or the mode was 60. You would call it the modal class. The modal class would be the 50 to 60 class, because that was the one that had the most pieces of data in it. So just kind of different ways of discussing modes and things like that. Cross tabulations. Cross tabulations are simply tables that display frequencies between 2 different variables. This is one of the things that you have to do in the mini project. So cross tabulations are frequencies for 2 variables when those variables have qualitative data. We only do it with qualitative data, i.e. things that aren't numbers, right? Now remember, sometimes qualitative data can be numbers, but only when those numbers don't actually equal amounts of things. Like if you had a list of jersey numbers for athletes, that would still be qualitative data, because the number 23 doesn't mean that athlete has 23 of something. It just is simply their label, right? It's their number. So qualitative data is just descriptive data. It's not numerical in value, right? And usually it means that it's words, it's not numbers. It's very rare to have qualitative numerical data. I mean, there's a few examples out there, like I said, jersey numbers and stuff like that. But anytime you see words, you know for sure it's qualitative. Anytime you see numbers, chances are it's quantitative. Madri?
Hey, so Dr. McBride, maybe I'm way off base here, but you keep saying the mini project, and so I don't see the mini project when I look at the homework assignment. I downloaded it from the Google Doc into Word, and I didn't see a mini project. So I'm wondering if I'm just 100% lost.
No. I think, hold on, so here it is. So under assignments, here's the mini project here. It starts in module 2 and it's due on the 28th.
Okay, so it's listed below that. Okay.
If you go to modules, right, it's down here in the bottom of module 2.
Okay.
And the mini project is just, you have that set of data that we just showed earlier, and you just have a bunch of questions. Well, not a bunch of questions, a bunch of things you're supposed to do. Like it says, generate frequency tables, generate cross tabulations, generate a Pareto chart, find the 5-number summary, right? So you're basically just generate a bunch of things on this data, and then you're describing each thing, right? So you generate a frequency table for the 3 categorical variables in the data set, i.e. the 3 qualitative, right? A categorical is also called a qualitative. And then you discuss those 3 things, like just a quick discussion of what you notice about each of the three variables. And then the same thing here, generate at least 2 cross tabulations. So you generate a cross tabulation, give a quick little discussion, cross tabulation, quick little sentence or 2 talking about it, 5-number summary along with this, right? A quick little summary. So that's all you're doing. So this whole annotate the output part is what students normally always fret about. They're like, what the heck does that mean? Well, it just means that this isn't a homework set where you're just simply having a bunch of answers and turning in answers. You want to digest those outputs, digest those answers, and then discuss them briefly. Just let me know that you know what the heck you're looking at. What does this stuff mean? Is there anything, does anything stand out? Is there anything interesting about the output? And, no differences is just as important as differences, right? So like if you were comparing 3 different things and you're like, oh gosh, all 3 of these things are very similar, that's an observation, right? Just like if you said, wow, this one's a lot bigger than the other 2, those kinds of things. So that's what you're looking for as far as the annotations are concerned.
Okay.
You good?
So for week 2, are we not, how are we describing? So like we are doing construct a pie chart. Are we constructing it and taking a screenshot and putting it on the week 2 practice exercise? Is that
Yes.
how we are submitting? Okay.
Yes. So if when you're doing the homework questions and it says create a pie chart, then yes, you want to create a pie chart in SAS or whatever technology you're using, right? You don't have to use SAS, but if you create a pie chart in SAS, then you want to use your snipping tool or some sort of screen capture, or even in SAS, there's a way that you can copy your output and then paste it into Word. All I ask is please don't take screen grabs of like the entire screen. So for instance, let me just do this. Okay, so data files, let's just load this really quick. Let's see, yeah, that's some decent data. Okay, so tasks, graph, pie chart, and I'm going to run it on the 1985 data, and this is going to look terrible, but I just want to show you. And there's my pie chart. Okay. Please don't take a screenshot of the whole damn screen. Take a screenshot of just this little rectangle that the pie chart's in and put that in your Word document. Because if you take a screenshot of the whole screen and put it in your Word document, it's going to be too damn small for my old eyes to be able to see it. So just take a picture of this. There's actually, if you up here, yeah, I think it's this one. If you do, print, then you could do that. But even that's gonna, be too big, right? So the best thing to do is to just do a screen grab. And if you don't know what the snipping tool is, Windows machines all have a snipping tool, and Apple, I think it's like the command key and like the Apple key or something, and it brings up a thing for doing just.
Yeah, on the Apple, Dr. McBride, it's going to be the command key, shift, and 4.
Thank you. Yeah, there you go. And then it lets you snip just a certain point, doesn't it? Not the whole screen.
Yes, sir.
Yeah, good. That's what you want to do, right? So it's going to be similar to the snipping tool, where you're just going to want to highlight just this piece and then go to the Word document and paste it into the Word document.
That's what it does.
Perfect. So any kind of outputs that you guys are making, so any graphs or anything that you're making, whether it's for homework or any of the projects, I want you to use that kind of snipping tool, whether either one, but I want you to be able to snip just the output and not all the extra junk.
So yesterday I was playing with the pie chart and I don't know what I did. I had to ultimately close the program and restart it. Instead of my pie chart, I did something. I had the concentric circles.
Circles. Yes, that happens all the time. And the reason why is you put something into your subcategory is what happened. I see
Okay.
that all the time. It's usually you put a variable into the subcategory. I think, let me see if I can, let's see if that does it. There it is.
Yeah.
Yeah.
And I could not get rid of them.
Yeah. You just got to get rid of your subcategories. Just hit delete and then rerun it. And there you go.
Okay, got it.
Yeah. But like you said, you can always just close the tab and reopen it too. Okay. So back to the frequency tables, right? A cross tabulation you can see is when your data is categorized two ways. So horizontally, this data is categorized by class rank, right? They were either freshman, sophomore, junior, senior. And then vertically, the data was categorized by whether or not they live off campus or on campus. And then all it does is it takes frequency counts of all those things. So there were 37 freshmen who lived off campus. There were 100 freshmen who lived on campus, and there were a total of 137 freshmen, just like there are a total of 231 students who lived off campus, right? So that's all a cross tabulation does, is it basically breaks down how your data fits into multiple categories. Okay. Questions on that one? Okay. Standard deviation. So those were all measures.
Sorry,
Yep.
Dr. McBride. Is
Go
it
ahead.
possible for you to take 2 minutes to show how to create that chart again? I couldn't browse to my data.
A cross tabulation one?
No, just the pie chart in the.
Oh.
Yeah.
So under tasks, there is a graph, and then under graph is pie chart, and it brings up this menu. And all you have to do is select your data, right? So the first thing you always have to do before you can do anything is you have to load data. So what homework question wants a pie chart? I don't remember.
Yes, maybe that's a piece I missed, the loading data.
Okay, so
I had
3.1.
imported all my data from the zip file last week, but how do I load it today?
Okay,
Yeah,
so all of your data should be in a folder somewhere.
I do have it in that folder.
Okay,
I created a data files.
All
yeah.
you have to do is double click the file, the data file, and you'll see that over here it created a tab that says exercise 3-1. So that's the data for 3.1. When you double click it, it loads it over here, but it doesn't actually load it into SAS. You always have to click the little running man to run it.
Got it. That's what I missed. Thank you.
Yep. And then once you run it, you'll see that this little display comes up and it tells you that it's been loaded. It tells you where it's been loaded. So your data was put into the work library and it was given the name import 1. You can change these by clicking change, but you just have to remember, okay, so 3.1 is an import 1. I always like to click on my output data tab just to make sure that it's sitting here. So I thought, okay, so once I see this, I know my data is loaded. So now if I go to my pie chart and I go, okay, I need my import 1 data, or if I click here, it brings up, my kind of like screen, my tree, and you can see here's the work folder where all the data gets stored. Here's input 1. And then now once I've done that, it's going to look at that data. So when I click the little plus symbol, it's going to come up with all of the variables that are in that data set. If I click on category of, let's say, expenditures, right? And because I want to run the data on expenditures, that's what it tells me to do. And I run a pie chart on that. Look what happens. Well, that's not right. The reason why this is wrong is because in the data set, each one of your expenditures, right? So here's the expenditure variable. It just has one number that shows up once, right? Because it corresponds to, okay, national defense spent this much, Social Security spent this much, and so on and so forth. So when you ask it to do a pie chart, what it's doing is it's going under the expenditure variable, and it's counting how many times the number 532 showed up. Well, it showed up once, right? They all showed up once. So that's why you get this stupid looking pie chart, which is not right. Instead, what you need to do is you need to add programs, right? And if you ran programs, look what happens. Same damn thing. Crap, under programs, it just lists the different program values and they all showed up once. I don't want to count how many times they showed up. I want to count them by their values. So instead of measuring by their frequency, I can measure by a variable, and the variable I add is the expenditure variable. And so now when I run it, now each pie chart shows the relative size based on the number that's underneath the expenditure variable, right? So for Social Security, it said 852. If we go back up here, we can see Social Security says 852. National Defense, 612, right? So now each of these pie charts corresponds to how much money was spent in each of those sections. So that's how it's all about learning how to use this tool. That's how to get it to do the output the way you want it to do the output, so to speak. But it all starts from running your data, right? The first thing you have to do is double click it and then hit the run. Okay.
Thank you so much.
Of course. So we talked about measures of center, the mean, the median, the mode. Now we have measures of dispersion, which is really just standard deviation, variance, range, and IQR, interquartile range. Those are really the main ones for measuring dispersion. Now, of course, variance and standard deviation are pretty much the same darn thing, because the standard deviation is literally just the square root of the variance, right? So if your variance is 100, your standard deviation is 10. It's just that simple. So those two measurements are normally never reported together. We normally only report the standard deviation, because there's no point in reporting the variance, because it's just the square of it, right? You just square standard deviation and you get variance. So we normally only talk about standard deviation. That's kind of the gold standard for talking about measures of dispersion. Secondarily would probably be range. Most people know what the range is, right? So the largest number minus the smallest number. So that talks about how wide your data is. And then there's this funny thing called IQR, interquartile range, which we'll talk about in a second. Well, standard deviation, I think we're all familiar with the phrase standard deviation. We might not be completely familiar with what the hell it tells us, but basically the standard deviation just tells us how wide our distribution is, how spread out our data is. So a really small standard deviation means everything's clumped together and our distribution would be really thin and tall. A larger standard deviation means things are spread out and we have a wider, shorter distribution because, and this is something we'll talk about in week 3, when you have a distribution, right? This is a curve showing the distribution of data. Well, this is what's called a probability distribution. It gives you the probability of various data values occurring. Well, just like probabilities always add up to 1, right? You know, probabilities are always percentages and they always add up to 100% or they add up to 1. Just like the probability of flipping a coin and getting heads is 1/2 and tails is 1/2. 1/2 plus 1/2 is 1, right? Probabilities always add to 1. Well, the area under these curves always equals 1. So that's why if it gets narrower, it must get taller. And if it gets wider, it must get shorter, because the area has to maintain its total area of being equal to 1. Now, to calculate standard deviation is a very complex formula. It's a lot of steps. It's not easy to do by hand. I would never suggest anybody to try and do it by hand. But you should be at least vaguely familiar with the formula, right? So standard deviation, go back, give me the pen, give me that color. So your standard deviation is the sum of all of your data values minus the mean squared all over your sample size minus 1, and then square root of that whole damn thing. So it's a very complex thing, but if you think about what's happening, you take each data value, here's an X, and then you subtract the mean from it. The mean's always the middle. When you subtract the mean from it, that basically gives you this distance. So we're taking the distance of all of our X's, some positive distances, some negative distances. And then we take each of those distances and we square them, right? So we take each distance and we square it. Then we add them all together and divide by how many things we have minus 1. Well, hey, adding everything together and dividing by how many things we have, that's an average. We're basically taking the average of these squared distances, and then we take the square root, which kind of undoes the square. And what we get is we get an average distance. So the standard deviation is basically the average distance from the mean. So if your standard deviation equals 1.2, that means that each one of your data values is roughly 1.2 away from the mean. Now, they can't all be 1.2 from the mean, right? Some are further, some are closer, but it just means on average, that's the distance from the mean to your data values. That's basically what it is. It's not exactly the average, but conceptually, to put it in your head so you can understand what the hell this thing is telling you, is it's roughly the average. Okay, some examples of small versus large standard deviations. The price of the same model of new cars would have a small standard deviation because, if we're talking about just one model of a car, there aren't a lot of differences between the options that they could have. So the difference in the prices aren't going to be that big. If we looked at the heights of a bunch of 30-year-olds, well, once you reach an age of 30, you've stopped growing. So everybody's heights should be fairly close to each other. Obviously, if we have like a Shaquille O'Neal or some big professional NBA player in there, or, a jockey, they're going to have, really tall and really small. But for average regular people, we're all going to have heights pretty similar. But if we look at the price of the same model of used cars, that's going to have a much bigger variation because now there's a lot more that goes into their price, right? How many miles they have, has it been in an accident, all this kind of crap. And also, if we look at the height of 7th graders, there's going to be a huge variation because kids are still growing at that point. So you can have kids that had growth spurts and kids that haven't, right? So you're going to have a bigger variation. So that's just what it means. Standard deviation is large when there's a bigger variation and smaller when there's a smaller variation. Well, sometimes the size of the standard deviation has a lot to do with the size of the data that you're looking at. For instance, if you were looking at the weight of mice, well, the weight of mice are all going to be in grams, and they're all going to be, like just a couple grams here or there, up to probably like 10 grams, somewhere around there is going to be the average. So the difference in those weights is going to be pretty small because you're going to be measuring it in grams. Whereas if you're measuring the weight of an elephant, which is in tons, well, sure, in tons is going to be pretty small. But if you were measuring the weight of elephants in pounds, you're talking about thousands of pounds. So your standard deviation is going to be much bigger because it's on a bigger scale, right? You're on thousands of things rather than just small amounts. Grams is just on ones and tens of things. So it's often not fair to ask the question, which of these two groups is more spread out, by simply looking at their standard deviations, because they're on two different units of measure, right? One is on grams, the other one's on tons, or one's on grams and one's on pounds. And even if they were both in pounds, right? So it's not so much that the unit of measure is different, but it's the scale. So like if they were both in pounds, it would really be hugely different because then mice would be fractions of a pound. So their standard deviation would be a fraction of a pound. Elephants are in thousands of a pound. So their standard deviation is probably going to be in like hundreds of pounds. So obviously you're going to think, well, God, then the elephant weights are more spread out because the standard deviation is like 103 pounds versus the mice is like 0.0001 of a pound. Well, that's not necessarily the case because of the scale of the data. So in order to compare apples and oranges, we take what's called a coefficient of variation. And simply all you have to do is take the standard deviation and divide it by the average of your set of data. And then that gives you something where it's been normalized, right? So you get a standard deviation divided by the mean. So now you're kind of dividing out that scale. Because this one over here, right, if we were in pounds, then 100 and something would be divided by 2,000 and something because that's how much it weighs, and then you get rid of that scale. So you can get, for instance, in this case, they're telling us that the standard deviation of mice was 2.4 grams. the standard deviation for elephants was 1 ton. But if we divide by the average weight of mice and the average weight of elephants, we get that the coefficient of variation is 0.258, and over here it's 0.455. What that means is your standard deviation is basically 25, 26% of the mean, and over here your standard deviation is 45% of the mean. So the elephants are more spread out, right? It's a bigger percentage. And that's basically what the coefficient of variation does, is it allows us to compare apples and oranges, right? Let's just compare 2 different groups of data that are on 2 different units of measure, so to speak. And that's pretty much it for the stats this week. The rest of this is just talking about how to work some of these things in SAS. Some of the questions I want to draw your guys' attention to. In 3.1c, you need to have the new percentage variable in order to do the question properly, because they ask you to do a pie chart for amounts, and then they also ask you to do a pie chart for percentages. Well, rather than have you guys create that new variable in Excel, I already did it for you. So if you'll look at the data in 3.1, you'll notice that there is the expenditure, and then over here there's the percent column. So that's the one you use when you want to do the percentage part of the question. In 3.4b, it says you can use the histogram graph, analyze variable scale to count, and use appearance tab to set the number of bins to 7. That's totally fine. And then our coding options make it look way better. So there's a bunch of different ways to do 3.4. You can do it the simple way by just messing around with the menus to make the histogram have 7 bins, but you can also do the coding option to make it look even better. It's up to you. I'm fine either way. With 3.4c, the same thing, just all you have to do is change the variable to percent. And then in 3.11, this is that one where you need to do a stem and leaf plot for each year, or use the code to make it in SAS. So stem and leaf plots, you can't do them really easily in SAS. You can do them really easily in Excel, but to do them in SAS, you have to use some coding. So 3.11 asks you to do a stem and leaf plot. And in fact, actually, I think if I remember correctly, I think the school removed 11 from the homework. Yeah, they did. So
Yeah, that's what I was wondering.
Number
I didn't
11 is
see.
not there.
yeah, it used to be there, and students just kept struggling with it, so they got rid of it. So yeah,
That's smart.
yeah. I mean, why should we make you guys actually learn something? Was always my argument. But yeah, so 11's no longer on there, so you don't have to worry about it. You do have to do a stem and leaf plot later, so I don't know why they thought we'd just get rid of it here, but anyhow, it's no longer on there. All right, so that's it. That's all I got for you guys. You guys have any other questions?
No, that's it for me.
Okay.
I have a question. I don't know if I should wait until Thursday, but
No time like the present, Sheena. Go for it.
the 3.4, I know I should know this, but every other question as I'm looking at it, I already know exactly what I'm going to do, but 3.4 is like blank for me.
Okay.
Do you mind covering 3.4 really quick?
Sure. So 3 point.
I'm gonna sign off, guys. Have a good night.
Thanks, man. You too. All right, so 3.4. Well, to determine the range, that's something that you can compute in SAS by just doing summary statistics. And then all you have to do is divide it by 7 to figure out how many intervals you want to use. And then all of this stuff is all kind of just playing around with SAS, right? When you want to compute, well, computing relative frequencies, that's something you kind of have to do by hand. So what relative frequencies are is back here. So these would be frequencies, right? So you would take your data, you would calculate the range, you would divide the range by 7, and then that would tell you how wide each of your bins needs to be. And then,
Okay.
and then it says, well, actually, it already tells you what it is. It tells you that the width is 0.05, and then it says if you use 0.705 as the lower limit. So basically, instead of these numbers, this is going to be 0.705 to let's see, 0.05 to 0.755, right? And the next one's going to be 0.755 to 0.805, and so on and so forth. And then what you would do is you would look at your data and go, okay, how many data values fall within this range? Okay, let's say let's just say these are the numbers. There's 5 in this one, there's and then there's 40 total. These are frequencies. Relative frequency just equals frequency divided by your sample size. So relative frequency would be 5 divided by 40 as a decimal or a percentage, right? So for instance, 10 over 40, we would just list as 0.25 or 25%. So that's how you do relative frequencies.
Okay. That helps.
Okay.
Thank you.
Of course. All right, so get going on the homework. Also get started on the mini project if you can, because you definitely want to always start those things early. And then when we meet Thursday, we can go over basically every question you have. So between now and then, the best thing to do is to do all of the homework, at least try as much as you can. And then anything that gives you trouble that you can't figure out, I can help you with it on Thursday. I can show you how to run it in SAS, and I can help you figure out, how to do it by hand and those kinds of things. So that's the best way to do it, is just now jump on all the homework, and then we'll talk about that on Thursday.
Dr. McBride, this is Christina. So I've
Yeah.
been working the homework problems, as you know, because I keep sending you questions about code and other stuff that I'm finding on the internet when I'm doing this. But
Yeah.
will you go over on Thursday just how to do the relative frequency histogram? Because hearing the way you just explained that, I'm pretty sure that I didn't do it right in SAS and for 3-4.
Actually, relative frequency histograms is actually really easy because you don't have to compute anything. SAS does it for you, right? So so here at 3-4, my data is loaded. If I go to histogram,
Mm-hmm.
and it was import 2, and I want to run it on relative frequency, and then hit run. There's my relative frequency histogram. Looks like crap, right? Go to appearance, bins, says the 7, try that. There it is, right? So you don't have to worry so much about computing things because it'll do it for you.
Okay, that's what I did. When I listened to you talk about computing the relative frequencies, because actually, I mean, SAS will actually compute the relative frequencies for the data set as well.
Yes, it absolutely will. Yeah. If you can, but can you get it? Can you get it to display it?
Yeah, I mean, I'm pretty sure that I did. Like I'm trying to remember how I did it. I'll have to look, but I thought, yeah, I exported a table.
Oh, perfect. Well, then you don't need to do it by hand. Yeah.
From SAS. And I mean, I'm pretty sure it's right because I understand like the formula of relative frequency. So when I just checked it, just to double check the math, I'm pretty sure. I'll have to see if I can remember how I did it.
Yeah, if you can remember how you did it, let me know, because then I'll put that in the SAS how-to document for everybody else.
I could be wrong, but I thought it was just actually when I ran the data. So like
when you just did summary statistics?
Or just like, yeah, like, or just, you know how whenever you just like load a data file and it gives you like the output.
Oh.
Maybe not. I have to remember what I did, but I mean, I can even send it to you just in an email so you can see what it looks like and tell me if I did it right. But well, like right there, doesn't that have the relative frequency?
Well, this has the relative frequencies only because I put it in this data set. I created this for you guys.
Yeah, but I know I pulled it. I'll have to find how I did it because I actually have it.
There should be I don't know if there's a way for it to calculate these for you, but I would hope there would be.
I think when I imported the data, it came with it. And that's why I was like thinking, because when I imported it, I saw some of the bins came with it.
Yes.
Well, yes, this comes with it because, like I said, I created these variables for you guys.
Okay, so I did import the right data.
Yeah,
We were
yeah.
supposed, okay.
Yeah. If you ever go to the homework sets and import the data from the homework sets, it's not going to have all the extra stuff, right? So like if you go to homework 2, there are links here to the data sets, right? So like this is 3.4. If you clicked on this and downloaded this data set, it's only going to have the original stuff. It's not going to have all of my extra stuff. My extra stuff is only if you go through our Google Drive.
So then
Yeah.
so just a question then on that, because like what she's saying, when I pulled it up, so I'm looking at what I put into the homework document, and it has a relative frequency on the interval ranges in the bins.
Right. That's because, again, because I created these.
Right, but so how is that different from the answer that you're looking for then?
It's
I
not.
guess.
It's
Okay.
not.
Okay.
It's
I'm
not
like,
different at all.
okay.
Yeah.
Okay. Do you want us to show you the longhand math of how I mean, I know how to
No.
do that. I just, okay.
No. Uh-uh.
Okay, got it. Okay, I just wanted to make sure I didn't do anything.
Yeah. No, I put a lot of these things in here for time savers because I didn't think it was worth your guys' time to calculate these things. As far as I'm concerned, those parts of that question aren't important.
Got it. Okay. Thank you. That's super helpful. I'm just
Yeah.
learning fast and I'm pretty dumb at it. So
There's a lot of stuff in here where I basically give you guys the information. I basically give you the answers. And whenever you come across that, don't think like it's something up. No, it just means I gave you the answer because I didn't think it was worth your time to calculate yourself.
So when we start working on our dissertation, would we have someone like you in our committee?
Not
Because
at Franklin, you won't. Nope. Franklin is very lacking in the stats department. So I have had several of previous students come back to me, a year or two down the road, begging for my help with their dissertations. So from what I see, no. The answer would be no. You'd be very hard pressed to find somebody